Hello, Professor and everyone. I'm Golnaz Mafazi, and today, in assignment number 1, we delve into the realm of traditional architecture when ingenuity meets sustainability. My home country, Iran's architectural heritage, boasts a prime example, the Badgir. It's more than just a solution to environmental challenges, it's a symbol of sustainable living, harnessing wind power to naturally cool spaces in warm climates. I'm going to divide this topic into 7 parts. I'd like to begin by talking about my home country, Iran. Next, the function of Badgir is described, and then we go on to the elements of Badgir, types of Badgir, its material, color, texture, and height. Next, understanding the role of Badgir in enhancing cooling efficiency is taught, and finally, there is a conclusion. Let's turn now to my home country, Iran. Iran, situated in the southwest of Asia, covers an expansive area of approximately 1,648,000 square kilometers. Bounded by the Gulf of Oman, the Persian Gulf, and the Caspian Sea, Iran's diverse terrain offers a captivating mix of landscapes. With a population estimated at around 78 million at the end of 2012, Iran boasts a rich cultural tapestry, with roughly one-third of its inhabitants residing in rural areas and the remaining two-thirds in bustling urban centers. Iran's geography is characterized by rugged mountainous regions, enclosing high interior basins and dominated by the imposing Zagros mountain range. Covering over half of the country's landmass, these mountains and deserts define Iran's majestic landscape. However, despite its breathtaking beauty, Iran is predominantly arid, with a majority of its annual rainfall average 250 cm or less, occurring between October and April. This dry climate is quite evident in many parts of the country, as shown in the picture of the extremely dry conditions prevailing in Iran. Understanding the geographic and demographic nuances of Iran is crucial for appreciating the environmental context in which traditional Iranian architecture, such as Badgir, has evolved. Moving on now to the function of Badgir, also known as wind catcher. In simple terms, the Badgir operates on two primary principles: the traction and suction principle and variances in temperature. Let's first explore the traction and suction principle. This function relies on attracting wind towards the openings facing it while creating suction through openings positioned against the wind. As wind encounters the internal blades of the Badgir, it naturally descends, drawing fresh air into the building and expelling hot and polluted air. When wind encounters an obstacle like the Badgir, air density increases on the windward side, creating positive pressure, and decreases on the opposite side, resulting in negative pressure. This pressure difference causes air to be drawn into the chamber through the wind-facing opening while expelling air through the opening opposite to the wind. Additionally, Badgir can facilitate moisture by transporting wind over damp surfaces or cold storage facilities, aiding in superficial evaporation. Now let's discuss the function based on temperature differentials. During the day, as the sun hits the southern face of the Badgir, warm air rises, creating a vacuum that draws in cool air from the inner core. Conversely, at night, as outside temperatures cool, cold air descends and is warmed by the heat retained in the parapets, creating a cycle of natural cooling. While there may be little emphasis on temperature differentials, the Badgir effectively harness the mechanism to provide natural ventilation and cooling, operating primarily on the principle of traction, suction, and temperature differentials. The next topic I'd like to focus on is the elements of Badgir. The Badgir comprises several essential components that contribute to its functionality and design. Let's explore these elements. Firstly, let's talk about the pillar, channel, or body. The Badgir's structure varies from cubes to prisms, often reinforced with wood for durability. These structures come in diverse shapes, such as square, rectangular, hexagonal, or octagonal, showcasing the ingenuity of ancient Iranian builders. Moreover, extensions beyond the Badgir serve as secondary frameworks for future maintenance and repairs. Moving on to the opening positions at the head of the Badgir. These openings exhibit various geometric shapes, including elongated, vertical and horizontal, rectangular and square, each serving a specific purpose in optimizing airflow. Next, we have the blades, crucial components of the Badgir's functionality. The design of the blade varies based on the Badgir's plan, with main blades conceived from external view and extending from ground level up to the ceiling. Slide blades, positions between main blades, serve primary aesthetic functions, enhancing the Badgir's exterior appearance. Lastly, let's not forget the roof. Constructed in the mound-like form, the roof enhances resilience against severe storms, ensuring the Badgir remains structurally sound even in adverse weather conditions. Now we are going to explore the diverse types of wind catchers, each exhibiting unique characteristics and functionality. There exists a variety of wind catcher types, which have been categorized based on several factors, such as the number of openings, number of stories, cross-section, and interior divisions. Let's start with the number of openings. Wind catchers are categorized by the number of openings they possess, ranging from 1 to 8. One-sided wind catchers, prevalent in regions like Ardakan and Maybudd, feature an inlet facing the north direction, directing cold northland winds indoors. Two-sided wind catchers, also known as twin wind catchers, are smaller in dimension compared to one-sided types and are commonly used by affluent individuals. Moving up the scale, four-sided and six-sided wind catchers offer variations in design and functionality, while eight-sided wind catchers are primarily utilized for water storage purposes. Next, we have wind catcher varieties based on the number of stories. Wind catchers can be classified into one-story, two-story, and occasionally multiple-story structures. While one-story wind catchers are the most prevalent, two-story wind catchers, though scarce, can be found in places like Amir Garden in Tabas City and Ahazadeh House in Abarkuh. There are even rare instances of wind catchers with multiple stories, such as the three-story wind catchers in Sadra Garden in Taft. Lastly, we delve into Badgir classifications based on blade positions. The positioning of blades within Badgir significantly influences their performance. Wind catchers with square, tetrahedral, or hexahedral cross-sections exhibit various blade configurations, including X-shaped, plus-shaped, and H-shaped blades. Each configuration impacts airflow differently, with sometimes being more prevalent than others. Moving on now to material, color, texture, and height. In traditional Iranian architecture, Badgir are carefully crafted using materials tailored to the local climate. In hot and dry regions, mud brick or baked brick with mud plaster is preferred, while in humid areas, plaster and starwood, which is a type of covering, are used for tolerance to moisture. Texture and color play crucial roles, with coarse mud plaster reflecting sunlight in dry regions and smooth, white finishes preventing heat absorption in humid areas. Height and design are also meticulously planned, with towers strategically elevated to capture wind and optimize ratios for efficient airflow. Despite regional variations, most towers are below 3 meters to avoid structural issues, with longer shafts in dry regions and shorter shafts in humid areas to enhance ventilation. This intricate balance between materials, design, and climate highlights the ingenuity of traditional Iranian architecture. Let's look now at understanding the role of Badgir in enhancing cooling efficiency. In regions with low humidity like Iran, Badgirs showcase sustainable architecture through evaporative cooling methods. These structures rely on natural ventilation, utilizing purpose-built openings and temperature differences to maintain human comfort. The increasing demand for cooling, driven by rising global temperatures and greenhouse gas emissions, has influenced the evolution of Badgir usage, particularly in hot, dry climates. Evaporative coolers, commonly known as swamp coolers, draw warm outside air through water-moistened pads to achieve cooling. However, they require significant water consumption, posing environmental concerns. Comparatively, Badgir offers efficient cooling with lower electricity consumption than conventional coolers. Its usage aligns with green energy policies, promoting comfortable and indoor environments while reducing energy costs and environmental impact. Now let's compare the experimental data from using Badgir versus an evaporative cooler. In comparing the cooling efficiency of Badgir and evaporative coolers, let's look at the data from two tables. In the case of using Badgir, we observed an average temperature decrease of 11.1 degrees Celsius and an average humidity increase of 20.8%. On the other hand, the evaporative cooler showed an average temperature decrease of 11.6 degrees Celsius. However, it resulted in higher humidity levels, averaging 22.75%. This comparison suggests that while both methods achieve comparable temperature reduction, Badgir maintains a slightly lower humidity levels, contributing to enhanced comfort for occupants. Moving on now to the conclusion. In short, the Badgir stands as a testament to the ingenuity of traditional Iranian architecture in harmonizing with nature to create sustainable living spaces. Through its utilization of wind power, the Badgir offers effective natural ventilation and cooling solutions, reducing reliance on energy-intensive cooling systems. As global efforts to address climate change and promote sustainability continue to grow, ancient practices like the Badgir provide invaluable insights into environmentally conscious design principles. By embracing and adopting these time-honored techniques, architects and urban planners can forge a path towards more resilient and eco-friendly built environments. Thus, the Badgir not only preserves Iran's rich architectural heritage, but also offers inspiration for innovative solutions to contemporary challenges in sustainable design. It is the end of my presentation. Thank you for your time and attention. I'm happy to answer any questions.